Hello, I'm Isaac Ajao. I'm back. I want to talk about simple linear regression, and I'm using R. And R Studio is the platform I'm going to use to demonstrate it. We have used Python, we have used SPSS, we have carried out this task using Excel also. Now it's time to use R, and R Studio will be used to execute that. You can see the question. It's on user engagement and session duration. Using the data provided below, this simple data, investigate the relationship between the number of user interactions during a session and the session duration. So conduct a simple linear regression to assess if increased user engagement leads to longer session duration. So we are saying that whether interaction will affect the duration of time you are spending. So these are the session ID, S1, S2, S3 up to 10. Then these are the interactions, and we have the duration in minutes. So this is supposed to be our X, supposed to be our Y. Independent, dependent. So we are regressing duration on interaction. We must know this before we go into writing code. Otherwise, we'll not get the expected results. So there are two ways. You can type this for beginners. I advise them to type on R Studio. For those that are well versed, if it's a complex data, like so many rows, so many columns, it's a simple thing to import. So let's go to R Studio. This is it. So already I've typed. And if you look at the, let me show you the data again. You can see the session ID S1, S2, S3. So instead of typing all these, you just use the command, the function paste. Function paste to do that for us. You can see paste, paste. You can see when you write this paste, paste O, we paste O will give you, maybe paste 0 will give you the S. You know, S is the first thing you see there. I see S. So it will just add all the value you have here. So this one is, it ranges between 1 and 10. So that will be 1, 2, 3 up to 10. S1, S2 up to, that is how to do it. Now interaction. Interaction, you can see 10 command like that, just the other one. Duration is this. So we want to see this session. Now let me just run this for us to see. You can see I've used data frame. It means it can come up like a table. Let me run this session, or let me just print this. Let's see. So this is the table. Now, as I promised that you can actually bring it. See, just say, let me say import. So import now. That is here. Import the Excel or CSV. So CSV, or import the data. So data can now be, we use read.csv. If it's on Excel, we use XLX. But I want to use .csv. So we make sure the data is already here. This is the data. I see this data already put it on Excel. So now I will now say read.csv name. Get the name very well. Simple linear. Let me input. Simple linear reg dot csv run. So since there are no error comments, so it means it's correct. You can now, let me see it. Put it here, just data. And just say print data run and see the same thing. Action, duration, session ID. And see, that's brought it. So it depends on what the way you want to. But I advise if you have a long data, you cannot be typing. Complex data, 1000 rows, 500 columns. It's better you import it like this. It's very easy. But I always advise my students to know how to do both. Now, okay, let's continue. We want to fit a simple linear. What even make this data a simple linear regression? Simple linear regression is when you want to fit a linear, want to test for a linear relationship, possible linear relationship between two variables, two continuous variables. One will be dependent, the other one will be independent. So, but when it's more than one independent variable, we talk about multiple regression. This is simple linear. So this is the model. You can see the model. LM is linear model. Duration is as identified as our dependent variable. So whatever thing you write here, RCC is as your dependent variable or response variable. You see, this is duration. Then the interaction is the independent. This sign, this approximation sign is you are saying it should regress. That is a symbol for regression. Regress, duration, or interactions. Then the source of data. Data is session data. You can see. Then you run it. When you run it, the model here, the result of this model is clearly seen. Let me put it here and show it to you. You can see this is the result of the model. So this is your intercept. You can see y equals 0.621 interaction. See this is intercept plus this. But to see the summary of the model, run this summary. See. See. So this is the model. I see 0.04. And I'm sure you can write this one out and look at the multiple R square. This is p-value, highly significant, showing to us that your interaction really predicts the duration. It's a good predictor. Then it's a good model because 97 points. This one shows that 97.4 variation. The response variable is explained by the model. So this is goodness of fit. It shows how reliable the data is. The model is when it comes to prediction. So this I want to extract. If you want to extract your coefficient, so this is how to do it. Intercept is this. Though we have seen the intercept from this place. This is the intercept. I want to extract it. I want to extract the slope. This is the slope. So now let me run this for us to see what I'm talking about. You see them coming out. You can see intercept is this. This is just for presentation. If you want to present your result where you want to let it look organized. So of course, but it has come out in the model. The model, the summary of the model has revealed it. Now let's visualize the question. Let me go back to the question. Okay, conduct a simple regression linear to assess if increase. Yes, you have answered that. You have answered that. Yes. If increased user engagement leads to longer session, yes. It has shown it. But the model, this model has shown it. The result has shown it. So as the interaction increases, the duration also increases. So it has answered that. Then let's now go to visualization. So what I try to do here, there's something we call scatter plots, scatter diagram in regression. You want to visualize the relationship that exists between the two variables. So we want to see it. So you have regressed session, duration, on number of interactions. I want to see the points. Though this 0.97 shows that it's a very good model, but we want to see it. How far are the points from the predicted line? We have a line, we call it regression line, or line of best fit. I see what I did here. Session data. So interaction is x, y is duration. Of because I've explained that. So the 0 point I want it to be data point. So the size is 3, it should not be too big. Then the regression line, the color I want, that regression line is what you call line of best fit. Is the line, those lines that the line is a product of the predicted values. So we want to have a legend also. I want it at the bottom. The bottom will give me the legend. Let me run. So see what I'm talking about. So you can see from this look at this line. Look at this line. This is the predicted. This is the predicted line. This line is produced from the predicted values. These are the actual values. These points are the actual values called data points. Or let me change it to actual values. Actual values. Well, it depends on anyone you want. What is important here is your understanding. So here you can see actual values. So regression line. So you can see that the points are not too far away from the line, so it's a good model. So here comes the end of this lecture. Make sure you go through and drop the code for you to practice. Thank you.